prove that for all values of n, where n is a natural number meaning positive integer, that n squared plus 2 is not divisible by 4. So we can do this by using proof by contradiction. And the first thing that you want to do for proof by contradiction questions is get an assumption. The assumption is the negation of the statement that we have here, so basically every other scenario to what we're trying to prove. And that would be, for at least one value of n, where n is a natural number, n squared plus 2 is divisible by 4. That would be every other scenario to this. So, if n squared plus 2 is divisible by 4 for at least one n value, then that n squared plus 2 is a multiple of 4, so we can say that n squared plus 2 is equal to, let's say, 4k, where k is some integer. If that's the case, we can rearrange this. We can make n squared the subject. I did this because now we can see that n squared is even. And if n squared is even, that must mean n is even. The only way you can square a number n to get an even number is if the original number n is an even number. An odd number squared wouldn't give you an even number. And then from this, we can let, again, so do a similar kind of thing, let n equal to, let's say in this case, 2p, where p is also an integer, and then put that back into one of the equations. So I'll put it into this one here. So then we end up with 2p all squared is 4k minus 2. 4p squared is 4k minus 2. And then I'll bring the 4k and the 4p squared together, keep the 2 on one side. I'll then divide everything by 4. So we end up with k minus p squared is a half. And actually here is our contradiction. K and p are both integers. And that means that k minus p squared must also be an integer. And as we can obviously see, half is not an integer. There's our contradiction, and therefore the original statement must be true. And then on to part 2. Given that x is a real value, the value of the modulus of 3x minus 28 is greater than or equal to the value of x minus 9. State, giving a reason, if the above statement is always true, sometimes true, or never true. Okay, so the statement is that the modulus of 3x minus 28 is greater than or equal to x minus 9. So let's just write that down. So the modulus of 3x minus 28 is greater than or equal to x minus 9. This is what we're trying to either prove it's always true, sometimes true, or never true. So we can do this by sketching some graphs. So we can sketch the graph of y is equal to the modulus of 3x minus 28 and y is equal to x minus 9 on the same set of axes, and then see if this function here is always above or touching this function here. Okay, so let's just first draw an xy axis. We'll start with y is equal to x minus 9, that's nice and easy. The y-intercept would be minus 9, which I'll put over here, let's say. X-intercept would be 9 as well. And then our line would look something like this. So this is minus 9, this is 9. And then for y is equal to the modulus of 3x minus 28, we first have to start by drawing the line y is equal to x minus 28. So the y-intercept for that would be minus 28, which is over here somewhere. And the x-intercept, if we were to set y to be 0, we'd end up with x is equal to 28 over 3, and 28 over 3 is bigger than 9. So the x-intercept would be just to the right of 9, and the line would then look like this. I've drawn the bottom bit as a dashed line because that's going to be reflected above the x-axis. So with modulus functions, we reflect what's beneath the x-axis to above the x-axis. So the y-intercept for that reflected line would be positive 28 over 3 over here somewhere. And below here was minus 28 over 3. And then just reflect this line up, like that. Okay, so what we see from these two graphs, if I zoom in, this bit here, where let's say this point on the left is A, this point on the right. So just to clarify that, this point here is A, this point here I'm going to call B. What we see is that the modulus function is above the line to the left of A and to the right of B. But in between A and B, the modulus function is beneath the line. This says the modulus function is greater than or equal to x minus 9. We see that that is sometimes true when we're considering x coordinates to the left of A and we're considering x coordinates to the right of B, but it's not true for x coordinates in between A and B. So therefore it'll be sometimes true. And then we can just give a little conclusion. That with the graph would be enough for the 2 marks.